I was working on the couch last night just with my laptop resting right on my legs. And I mean, within maybe 20 minutes, it felt like I was incubating a small star.
Oh, yeah, you got that classic sigh burn.
Right. And it just, it sparked this daydream for me about a future where, our hardware runs at these blazing speeds without generating all that massive heat, which is actually the exact mission of our deep dive today.
It is, yeah. We're really looking at a pretty monumental leap in computing hardware here.
Exactly. Scientists just synchronized 105,000 nano-oscillators in only 45 nanoseconds, which is, I mean, wild. But before we get too deep into the weeds, this deep dive is actually sponsored by Embersilk. So if you need help with AI training or automation, integration, software development, really just uncovering where agents could make the most impact for your business or personal life, you should definitely check out embersilk.com for your AI needs.
Yeah, highly recommend them. But getting back to these oscillators, it is a staggering breakthrough from researchers at IIT Bhubaneswar, the University of Gothenburg, and Tohoku University.
Right. Okay, let's unpack this because to understand how this prevents our laptops from melting, we really have to look at how it processes data differently, right?
Exactly. So instead of physically moving electrons around a chip, like moving cars through traffic, they're using spintronics, specifically spinval nano-oscillators.
So since you all listening know we're trying to move beyond like traditional silicon bottlenecks, how exactly are these handling data differently?
Well, they rely on the electron's spin rather than its physical movement.
Okay, right.
By running a tiny current through the material, they aren't pushing electrons from point A to point B. They literally just alter the direction they're spinning right in place.
Okay, so I'm picturing like a stadium wave. The fans, the electrons aren't, running around the arena. They just stand up and sit down in place. But the wave itself travels instantly.
That is a perfect way to look at it. And because these oscillators are incredibly tiny, like 10 to 20 nanometers wide, the spin wave of one just ripples right into the next.
Oh, like dropping thousands of pebbles into a pond.
Yes, exactly that.
But wait, if you drop 105,000 pebbles into a pond at once, you'd expect chaotic splashing, right? Like, how does the signal not become completely garbled? Is this like a quantum computing situation where you need absolute zero temperatures and intense error correction just to keep it stable?
No, and what's fascinating here is that it's the exact opposite of that. They don't splash chaotically. Through those spin waves, they naturally lock into the exact same rhythm.
Oh, wow, really?
Yeah, they amplify each other into one massive unified wave, and it happens so fast. A network of 100 oscillators took about 10 nanoseconds to sync.
Okay, that's pretty fast.
Right, but scaling all the way up to over 100,000, it only took 45 nanoseconds.
Wait, really? And the signal remains clear?
Perfectly clear. They achieved a quality factor of over 1 million, and as the network grows, the signal line width actually decreases.
Wait, what do you mean by line width decreasing?
Right, so imagine a radio station with, static bleeding into neighboring channels. A narrow line width means the signal is laser focused on one exact frequency.
So no static at all?
Exactly, zero static. It's like striking a tuning fork and getting a single perfectly exact pitch. Just pure harmony.
Man, here's where it gets really interesting because stabilizing a signal that clear in 45 nanoseconds is, it's like a regular CPU executing an operation across an entire matrix instantly.
Yes, it is. And if we connect this to the bigger picture, because these oscillators naturally interact and synchronize, they perfectly mimic biological neural systems.
Neuromorphic computing.
Exactly. They act just like neurons firing together in a human brain.
So if they act like neurons, does that mean this hardware is practically purpose-built for AI models?
Yeah.
We wouldn't need to force software to simulate neural networks.
You hit the nail on the head. We are looking at a total hardware revolution for AI accelerators and, real-time data analytics.
And those Ising machines too, right? Those processors built specifically to solve those mind-bendingly complex logistics problems.
Precisely. They can map out massive logistical networks instantly while consuming just a tiny fraction of current energy needs. It's such an optimistic step for human innovation.
It really is. And, I want to leave you with one final provocative thought from the research. What if these systems transition to antiferromagnetic materials?
Oh, that is incredibly exciting because antiferromagnets operate in the terahertz frequency range, which is exponentially faster than what we're doing now.
And crucially, they have zero net magnetization, right? So their internal magnetic structures cancel each other out, meaning our future computers could be completely immune to magnetic interference.
Exactly. No magnetic data corruption, unprecedented speeds,
Yeah.
and highly, highly energy efficient.
Just a brilliant, completely positive future for computing. No more laptop burns, just pure, uninterrupted speed, unlocking new solutions for humanity. Well, if you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.